Good morning students, welcome to our online video class of chemistry. In previous section, we had discussed about some physical quantities such as volume, mass, temperature, density, etc. Today we will discuss about scientific notation. As chemistry is the study of atoms and molecules which have extremely low masses and are present in extremely large numbers. In chemistry, we have to deal with the large numbers and small numbers. Not only in chemistry, all sciences. In science, we have deals with some very large numbers. For example, 1 mole. It is given here. It is very difficult to write and count with such large number involving zeros. The example for science deals with small numbers are mass of electron. Here also it is very difficult to write and count with such large number of zeros. And this problem is solved by using scientific notation. And the scientific notation is the method of representing very large or very small number in the form of m into 10 to the power of n. Or we can write capital letter N into 10 to the power of n, where m or n is a number between 1 and 10. This is also called a base or coefficient, where n is an integer or exponent having positive and negative values. In scientific notation, a number is written as the product of two numbers. The first number is called the base or coefficient, that is n. Then the base is a number between 1 and 10 and is usually written with only one digit in front of the decimal point. We can write only one non-zero number in front of the decimal point. The second number is the power of 10. The small numeral 3 in 10 to the power 3 is called the exponent. The exponent indicates how many times the coefficient must be multiplied by 10 to equal to the number in question. Let's do some examples for scientific notations. This number is given in the form of standard form. We have to convert it into scientific notation. How we can represent a scientific notation? N 10 to the power of small letter n, where small letter n is the exponent. It may be positive or negative. And capital letter N is the coefficient. In scientific notation, only one non-zero digit before the decimal and rest of the number put after the decimal. So we can put the decimal only in between 3 and 0. 3.040. Here we move the decimal point 3 places to the left. Thus the equation becomes 3.040 into 10 to the power of 3. And what will be the sign of 3? Here the decimal point moves to the left. If it moves to the left, the sign becomes positive. Let's do another example. 0.00016. The decimal point should be placed between 1 and 6. 1.6 into 10 to the power. What will be the exponent here? Here we move the decimal point 4 places to the right. Then the exponent n is 4. What will be the sign of 4? The decimal point is moves 4 places to the right. If it is right, then the sign becomes negative. We can also convert the scientific notation into standard forms. 1.5 into 10 to the power of 4. How we can convert it into standard form? Here the exponent is 4 and it is positive. If the exponent is positive, move the decimal point towards the right. In this case, the exponent is positive 4. Move the decimal point 4 places to the right. So we can write it as 15,000. Let's do another example. The number is given in the form of scientific notation. We have to convert it into standard form. Here the exponent is 2. So here move the decimal point 2 places to the right. So we get 2, 3, 2.508. Consider another example. 5.8 into 10 raised to minus 4. This is given in the form of scientific notation. We have to convert it into standard form. Here n is exponent and n is minus 4. So we have to move the decimal point 4 places to the left. The number becomes 0.0058. Since all numbers in scientific notation have base 10, we can always multiply them and divide them. Next, we are going to study about multiplication and division in scientific notation. Multiply two numbers in scientific notation. Multiply the coefficients. Here the coefficients are A and B. A and B multiplying. Then add its exponents. What are the exponents here? N and M. Add the exponents. Divide two numbers in scientific notation. First, divide the coefficients. Then, subtract the exponent. In the case of multiplication, we can write 10 raised to a into 10 raised to b equal to 10 raised to a plus b. If it is the case of division, 10 raised to a divided by 10 raised to b, we can write it as 10 raised to a minus b. Let's see some examples for multiplication and division. Here 5.6 into 10 to the power of 5 into 6.9 into 10 to the power of 8. In multiplication, what we have to do? First, multiply the coefficients. Here the coefficients are 5.6 and 6.9. So we get 5.6 into 6.9. Then add its exponents. Here the exponents are 5 and 8. Thus we can write it as 10 raised to 5 plus 8. 5.6 into 6.9 into 10 to the power of 5 plus 8. Thus we get 5 plus 8 is 13. So we get 10 raised to 13, which is equal to 5.6 into 6.9 into 10 to the power of 13. 5.6 into 6.9 equal 38.64 into 10 to the power of 13. In scientific notation, we have only one non-zero digit before the decimal. So we can write this as 3.864 into 10 to the power of 14. In the case of division, first divide the coefficient, then subtract the exponents. 2.7 into 10 to the power of minus 3 divided by 5.5 into 10 raised to 4. This we can write as 2.7 divided by 5.5 into 10 to the power of minus 3 minus 4. That is equal to 0.4909 into 10 to the power of minus 7, which we can write as 4.909 into 10 to the power of minus 8. Next is addition and subtraction in scientific notation. For these operations, first the numbers are written in such a way that they have the same exponents. So we have to make the exponent as same. After that, the coefficients are added or subtracted as the case may be. Thus, for adding 6.65 into 10 raised to 4 and 8.95 into 10 raised to 3, exponent is made same for both the numbers. Here, the exponent for one is 4 and other is 3. So, we have to make same. Thus, we get 6.65 into 10 raised to 4 plus 0.895 into 10 raised to 4. Then these numbers can be added as follows. Thus we get 6.65 plus 0.895 into 10 raised to 4 equal 7.545 into 10 raised to 4. The subtraction of two numbers can be done as, consider the example, 2.5 into 10 to the power of minus 2 minus 4.8 into 10 to the power of minus 3. So here we have to make the exponent same. To make the exponent same, 4.8 into 10 raised to minus 3 can be written as 0.48 into 10 raised to minus 2. Thus we get 2.5 into 10 raised to minus 2 minus 0.48 into 10 raised to minus 2, which is equal to 2.02 into 10 raised to minus 2.